In section 311, we're talking about rational inequalities instead of polynomial. So what this adds in is that you are going to have excluded values that regardless what in the world happens, you are never, ever going to have those included in your solution set. So this is one of the only times that you can have brackets and parentheses in the same answer. So the beginning of these kind of look very similar. You have to get all the terms to one side. You want to make one big fraction if there are multiple fractions. You want to then determine excluded values. So these are not included in the solution set, and these are things that make your denominator equal to 0. Then you're going to make your two decisions just like we did before. Find your zeros, use the number line test values in the sign chart, and then you will write down the solution is. So these work a whole lot the same way. It's just that you've got that added excluded values that you have to consider. So let's do an example. So this one, we have everything to one side, and you are looking at this, and we want to decide what happens if I factor. So if you're able to factor, you want to do that first. So we have x plus 6 and x minus 6. Now, the first thing I'm going to do is look at this denominator and figure out excluded values. So those are going to be any x that makes your denominator go to 0. So this one will have 2. So the first one is x cannot ever be equal to negative 6. And it also cannot ever be equal to positive 6. So those cannot be in the solution set. And these will always go on your number line. All right, so now we're going to find our zeros. And remember from rational expressions that zeros are anywhere where the numerator is equal to 0, so that's going to be at x equals 5. Now, we don't have any holes with this, so we don't have to worry about that. So now we're ready to make our two decisions. So the first decision is that it's less than 0, so we're looking for negatives on our number line. And then it doesn't have the line under it, so we do not include the zeros. So we do not include the zeros. So we are ready to have our number line. So on the number line, we're going to have the number negative 6. We're going to have the number positive 6. And then we have to back up because we have to put 5 in there as well. So again, we are looking at test values. And this time, our test value is going to have to go into both the numerator and the denominator. And again, I don't really care what the actual numbers are. I just need to know what the sign of it is because we want it to be negative, meaning that it's below the x-axis. So we're going to choose test values to plug in for each one of these x's here. So we got one right there, and one right there. So the first test value that I'm going to choose is going to be negative 7. So in the numerator, if I have negative 7 and I subtract 5 from it, that's a negative in the top. In the bottom, if I plug in a negative 7 plus 6, that's also negative, and then a negative 7 minus 6, that's a negative. So the top stays negative, the bottom turns into a positive. So a negative divided by a positive is going to give me a negative value. So negative is what we want from up here. So this is included in my solution set. So I do this. And then I'm looking at 6, and I'm seeing right here that x cannot be equal to 6. So I know that regardless what else happens, that cannot be included. So that section is situated. So now I need to go between negative 6 and positive 5. I'm going to choose a 0 and plug them in for my blue x's that I have highlighted. So I have 0 minus 5 is a negative. In the bottom, I have 0 plus 6, so that's a positive, and then 0 minus 6 is a negative. So a negative divided by a negative makes that whole set positive, but we want, again, the negatives up here, so this is not in my solution set. Now, between 5 and 6, I'm going to have to use a decimal or a fraction, so I'm going to use 5.5. If I have 5.5 and I subtract 5 from it, that's going to leave me with a positive in the top. 5.5 plus 6, of course, is positive, but then 5.5 minus 6 would be negative. So that whole section is negative. So this is included in the solution set. So this goes here. Now, 5 is a 0, and we decided that we are not going to include that. So it's a parenthesis. And then we know that positive 6 over here, I underlined the wrong one a minute ago, it's also not included. So even if that last section is included in the solution set, you cannot include the number 6. So last but not least, we go to the right of 6 for a test value. That's going to be a 7. As we substitute those into the blue highlighted X's, I have 7 minus 5 is positive, 7 plus 6 is positive, and 7 minus 6 is also positive. So that whole set is positive. But again, we want a negative value that we made the decision on, so this is not in my solution set. So all of my testing is finished, and I'm looking at my number line, and I can say that the solution is, and our solution set is, and we're always going to start from the left and go to the right. So I'm going to have negative infinity up to but not including negative 6, and then union, because all the numbers between 5 and 6 will also work. Next example looks much like the last. It's already factored for me, so I don't really have anything that I have to algebraically do at the beginning. So when I'm looking at this, first thing I'm looking at are the excluded values. So that's where the denominator cannot ever be equal to 0. So that's when x cannot be equal to 1. So no matter what happens, that will not be included in the solution set. So the next thing I'm going to do is find my zeros. So again, knowing from rationals that means that the top has to be equal to 0. I have 2 factors up there, and those are equal to 0. So x is equal to negative 12, and this one says that x is equal to positive 4. And now I'm ready to do my 2 decisions. So this says that this function is greater than 0, so I'm looking for positive as I put it on the number line. And then I have the line underneath, which means I include my zeros. So on my number line, we are going to put our smallest number is negative 12. Our next largest is the number 1. And then to the right of that, we'll have the number 4. As we choose our test values, we're going to be plugging them in for this x, and this x. So when we go to the left of negative 12, let's use negative 13. So negative 13 plus 12 is a negative. Negative 13 minus 4 is another negative. And then negative 13 minus 1 is a negative. So this is a positive divided by a negative, which is negative. So what we want are positive numbers. So this is an O. All right, between negative 12 and positive 1, I'm going to use a 0. So we have 0 plus 12, we have 0 minus 4, and we have 0 minus 1. So negative divided by negative makes it positive, and that is, again, up here, the decision that we made. So this is in my solution set. So I shade this. We are including our 0, so this is a bracket. And 1 absolutely cannot be included, so this is a parenthesis. All right, between 1 and 4, let's use 2. So 2 plus 12 is positive, 2 minus 4 is negative, and 2 minus 1 is positive. So this is negative, but we want the positives, so this is not in my solution set. And then bigger than 4, let's use 5. We have 5 plus 12, 5 minus 4, and we have 5 minus 1. So this one is all positive. So this is a yes. And 4 is a 0. So we said that we will include our zeros. So this is a bracket. So at this point, we're ready to talk about our solution set. And you need to be very, very careful about making sure that I can read whether it's a bracket or a parenthesis, because I'm not guessing. If it's not there and I can't tell which one it is, I can't give you credit for it. So this is a bracket with a 12 up to 1, and then union 4 to infinity. So with this next example, you have to bring the 2 over, and when you do this, you're going to have to get a common denominator. So I'm pulling this over as a negative 2 over 1, and we need the common denominator to be x plus 7, so we have to multiply that top and bottom. So I'm multiplying by 1. And that's now going to be less than 0. So I have x plus 1 minus 2x, then minus 14. Don't forget that second negative. Our denominator that we came up with was x plus 7, and that's less than 0. And then we combine like terms in the top. So I have a negative x minus 13, and that is divided by x plus 7 is less than 0. Now, you've got the option right here to factor out a negative 1, so you're going to have x plus 13 over x plus 7 is less than 0. And then if I multiply both sides by a negative 1, that'll make that into positive 1. But again, because I have multiplied by a negative, this will switch places, or switch directions, excuse me. So this is x plus 13 over x plus 7 is now greater than 0. So excluded values first. So our denominator cannot be 0, and that occurs when x is equal to negative 7. So it cannot ever be equal to that. That will not be in the solution. And then we have only one 0, and that 1 0 is when x plus 13 is equal to 0. So we have x is equal to negative 13. So our two decisions, this says that my function is greater than 0, so we're looking for positives. And I do not see the line underneath, so we do not include the zeros. So on my number line, we are going to put the numbers negative 13 and also negative 7. I know that the excluded value cannot be included, and in our case, we also cannot include our zeros. So regardless what happens, neither one of those can be included. So for our test values, I'm going to choose a negative 15 over here. I'm plugging it in for this x and also this x. So when we do that, we end up with a negative 15 plus 13 is negative, and then negative 15 plus 7 is also negative. So that whole section is positive, meaning it's above the x-axis. And we are in fact looking for positives, so that section is included in my solution set. So it goes off to negative infinity over here. Between negative 13 and negative 7, I'm just going to choose negative 10. You can choose any number between there though. So negative 10 plus 13 is positive in the numerator, and then negative 10 plus 7 would be negative in the denominator. So a positive divided by a negative is of course negative, and since we're looking for positive numbers, then this is not included in our solution set. And then to the right of negative 7, I'm going to choose 0. 0 plus 13 is positive. 0 plus 7 is also positive. So that whole section is positive, and that is what we're looking for. So this section is included in my solution set. So I'm now ready to write my solution set. So the solution set is and I read left to right, so I go negative infinity to negative 13 with a parenthesis, and then we union from 7 to infinity because that's also included. The next example already has everything to the left of the function, so I'm ready to make my two decisions. So first off, it says it's greater than 0, so I'm looking for positives. I'm also looking at the fact that I have this line under here, so I do include my zeros. So I'm going to go ahead and factor. So factoring the top, we get x minus 4 times x minus 6. And factoring my bottom, I have x plus 8 quantity squared. And I'm writing it that way because anytime I square something, I end up with a positive. So what that does for me is I don't have to put my test values into this function for the denominator x, because it doesn't matter what I get. When I square it, it becomes positive. Now, excluded values are when x plus 8 squared can't be 0, so that occurs when x plus 8 can't be 0, so that occurs when x is equal to negative 8. So that's my excluded value. My zeros are, of course, when I take the top. So I have x minus 4 equals 0, so x is equal to 4 is one of my zeros. My other is when x minus 6 is equal to 0, so that's when x is equal to positive 6. So I'm ready to put those on my number line. So I have negative 8 cannot be included. 4 can be if that's part of my solution set, and 6 also can be if it's part of my solution set. All right, so we're negative infinity out here and positive here. So switch over to red because now we're using our test values. Now the test values are going to go here and here. You can put them here if you want to, but hopefully you'll recognize that when you put them in the denominator and then you square the answer, you're always going to get a positive. So I can go ahead and do that across through here. I know that every single denominator is going to be positive. I don't have to calculate it. That saves me time. To the left of negative 8, I'm going to choose negative 10. So negative 10 minus 4 more is negative. Negative 10 minus 6 is negative. So the top becomes positive. The bottom is already positive, so this whole thing is positive. And as I look up here, that's what I'm looking for. So this section is a yes. That is included in my solution set. Between negative 8 and 4, I'm going to choose 0. 0 minus 4 is negative. 0 minus 6 is also negative. So again, I've got a positive divided by a positive, so this section is yes. So that is part of my solution set as well. So between 4 and 6, 5 is an obvious choice. 5 minus 4 is positive, but 5 minus 6 is negative. So this section ends up being negative, so this is a no. So I'm going to include the 4 because that is one of my zeros, and I do include that. And then to the right of 6, I have 7. 7 minus 4 is positive, and 7 minus 6 is also positive. So that whole section is positive, so this is a yes. So this section is also included, and I do include the 0 that is at 6. So we're ready now to talk about our solution set. The solution set is reading always from left to right. So we'll have from negative infinity to 8, but I can't include it, so I have to make that a parenthesis and then I union. So I can also include the numbers that are between 8 and 4. Only the 4 is inclusive. And then we union that because I have a third set that goes from 6 to infinity. So be very careful as you do your sign charts. As we start our next example, we are noticing that we do not have everything to one side. So the first thing I'm going to do is to subtract 4x and put it over 1, and I know I have to get a common denominator. So I multiply the bottom by 3 minus x and the top also by 3 minus x. And this is still greater than or equal to, and since the 4x came to the left, this is now greater than or equal to 0. So as I start to simplify on this side, I have 4x minus 12x plus 4x squared. And this is divisible, this is being divided by a denominator of 3 minus x. Notice this negative goes only to the top, not the bottom. So this is greater than or equal to 0. Now, for both of these, I'm going to go ahead and put them in descending order. So I have 4x squared minus 8x. Also combine that like term in the top. And then in the bottom, we have negative x plus 3. And this is greater than or equal to 0. And at this stage, I can factor in the numerator. I'm going to go ahead and factor out a 4x. So this leaves me with x minus 2 in the top. So I have two different factors here. And then in the bottom, I have a negative. And then this is going to leave me with x minus 3, greater than or equal to 0. Now again, because I have this negative that was able to be factored, I'm going to go ahead and get rid of it. So if I multiply this fraction by negative 1, then those cancel each other out. And when I can't multiply over here by negative 1, that stays 0, but that does not stay. So this is 4x, and then I have x minus 2, and then this is x minus 3. Now this is less than or equal to 0. So making sure that you get the left-hand side as simplified as possible will help you in your process. All right, so I have all the things to find. So if this is less than 0, I'm looking for negatives. If it has the line under it, then I include my zeros. Then we talk about our excluded values. So this one only has 1. It's when x minus 3 is equal to 0, so it can't be that. So I have x cannot ever be equal to 3. And then for my zeros, I have 2 of those. I have 4x equals 0, and that only occurs when x is 0. And then I have x minus 2 is equal to 0, so that's when x is equal to 2. So we're ready to put this on our number line. We have a 0, we have 2, and we have 3. To the left of 0, I have, let's use -1, and these are going to go in here, here, and here. So 4 times -1 will be negative. -1 minus 2 more is also negative. And then -1 minus 3 more is also negative. Now this entire section then is a positive divided by a negative, which is negative. And as I look at this, that's what I'm looking for, so this section is a yes. Now we are including our zeros, so 0 would be included. I'm not going to bracket that yet because I have to figure out what's going on to the right of it. So between 0 and 2, let's use a 1. Plugging those in, I have 4 times 1 is positive. 1 minus 2 is negative, and then 1 minus 3 is also negative. So this ends up giving me a positive, which I do not want, so this one is not included. So since 0 is a 0, and I am including those zeros, then that's bracketed at 0. Between 2 and 3, I'm going to use 2.5. So 4 times 2.5 is positive. 2.5 minus 2 is still positive. And then 2.5 minus 3 is negative. So a positive divided by a negative is negative. So this section is included in our solution set. Now, regardless of what's going on, that cannot be included because it's an excluded value. 2, however, is a 0, so it is included. Now, to the right of 3, I'm going to choose 4. 4 times 4 is positive. 4 minus 2 is also positive. And then 4 minus 3 is positive. So that whole section ends up being positive, and it is not included in my solution set. So we're ready to say the solution set is. And we're going to read that from left to right. So I have negative infinity up to and including the number 0. Then we union, and we include 2 because it was a 0. We do not include 3 because it was an excluded value.